so let us optimize. We want to find the absolute max and min of f of x is x squared plus 4y squared minus 2x squared y plus 4 above negative 1 is less than x is less than 1 and negative 1 is less than y is less than 1. What shape is that?
Circle. Speedy or circle? Or sphere or something. Not circle.
Okay, so the x's are allowed to range between negative 1 and 1. So that's this stuff, including the n's, right? And then the y's are allowed to range
Negative 1 to 1.
including the n's.
So we have a nice little square.
Yeah, it's square, because I'll see that.
No.
This
you're
point
talking
in
about
particular,
function.
right? Negative 1, 1. Is that in there or not? Yeah, because the x value is negative 1. That satisfies this first guy, and the y value is 1. That satisfies the second guy. Okay, so I got a closed box, right? I kind of gave away the next part. It's closed, right?
Yeah.
Why is it closed?
Because we're including all the edges.
Because we included the edges. Is it bounded?
Yeah.
Yeah. What's the smallest disk it fits in?
One.
How about what's a safe bet for the disk it fits in? The radius. 1?
Half.
Radius of 1.
No, don't be nuts.
You would cut the corners off.
Yeah, you'd cut the corners off, right? A radius of 1 would look like this. So you'd be missing some stuff.
Radius of 2.
So a radius of 2 would be a safe bet, right? What's the smallest radius you can get away with?
Square root of 2.
Square root of 2. Right? Because that's how far this is. Crazy, right? Okay, so closed, bounded, so I know it has a max and a min. How do I go about trying to find them?
How do you know it's a square again?
Take some partials.
So it's a square because the x's are restricted to negative 1 to 1, and the y's are restricted to negative 1 to 1. But there's no relationship between them, right?
Yeah.
So as long as the x value is between minus 1 and 1, that's anything in this strip, right?
Okay.
And the y value is between minus and 1, that's anything in this strip. If it has to satisfy both of those, it's got to be in the intersection of the two strips.
And so are we assuming that it's including all z values for f of x, y?
Yeah, so we've got a function over a closed and bounded set, right?
Okay,
So I know it's got a max and a min, and that surface looks something like this out here, right?
right.
It's some kind of draped handkerchief over this, and I have no idea what it looks like. But I know it's got a top and a bottom, because this thing has hard edges on it, right? And I've got a nice continuous function. Cool. So someplace there's a highest point that draped handkerchief achieves, and someplace there's a lowest point that draped handkerchief achieves. But I don't know where they are. So how do I try to find them?
Take some partials.
Take some partials? Okay, so I want to find out about, like, gradient of f. Nice. Y minus 2x squared. Cool. Okay, so that's going to tell me I've got 2x minus 4xy is 0, and 8y minus 2x squared is 0. Okay. What do you solve?
Good song.
Let's say solve the bottom one in terms
Oh,
of x.
or we can multiply.
plug it in.
Multiply the top one by x.
Bottom
Like
line.
x
I was gonna
plus
say, yeah, can we multiply top side by x?
This guy?
Yeah.
And then add them?
Yeah.
Well, you're
Okay.
still gonna have x's and y's.
Yeah.
Well, you're gonna have
Yeah, I think you're still going to have x's and y's. So what I would advise for is looking at this first one and seeing that you can factor something out.
Factor out the x.
factor out
2x.
Yeah, you can factor out a 2x, right? So I factor this. I get 2x times, what is 0?
So
1 minus 4y.
1
2y.
minus
2y.
2y.
Oh, yeah, 2y.
Okay, so x equals 0 or y equals
Okay, so I find out that either x is 0 or y is 1/2. What's the y that goes with x is 0? Is it 1/2? Like, is this a point that I found?
one.
No,
No.
plug in.
No, you have to check the other. Yeah, you check the other one.
Yeah, so if I plug x is 0 into this one, I get 0, right? Equals 0. Check. If I plug 0 for x in here, what do I get for y? 8y is 0. That tells me y is 0, right? You guys see that? So when I do the 0 product rule, right, I get or. This is 1 point, and the other point is y is 1/2. What's x?
halves of 4s.
That would be 2
Root 2.
Root 2.
I got 4 minus 2x squared is 0. So that looks like x is root 2 to me. X is root 2.
Both those points
Sure.
already know.
Wait, are you sure?
Plus
Plus or
Where'd you get
minus?
the 4 minus 2x from?
Where'd I get the 4 minus
Yeah.
2x squared? Okay, I had a y, right? I
Yeah.
didn't know what the x value that went with it was. So I took this y and I thought about what if I plugged it into these.
Okay.
Out of those I get that one, and out of the top I get 0 equals 0. 0 equals 0 doesn't help you, right? But this guy will fiddle around eventually to x is plus or minus the square root of 2.
Neither of those points are in the bounds.
Ah, and the x values for this guy are outside the bounds, right? You see that? So I don't care what these are. Right? They could be a max, they could be a min, they could be a saddle. I give exactly 0 craps about these 2 points. But there are 2 of them,
Well, you gotta
right?
pick the left side of the shape.
Cool. Alright, so I got x is 0, y is 0. What do I do with that information?
Oh, we're not including the y because it's the bounds.
Yeah, because the x values are too big.
Is that why you think about what this
Yeah, or I could just check, right? Is the x value between minus 1 and 1? Well, square root of 2 is too big.
Well, it's like we just totally like just remember that fact that I just didn't care. So I mean, like if you like wrote down with this infinity, the radius is 2.
Yeah, that might make me think that it fits, right? That I would use those. But those are definitely out here, right? They're square root of 2 out, so they're here and here. And then they're up a half unit, so they're like here and here. It doesn't even matter what they are, because they're not in the thing I'm talking about, right? They're kind of outside your allowed universe.
So we have one flat spot.
So it seems like, yeah, it seems like I have one flat spot. I was supposed to find a max and a min, though, right? Yeah. Oh, okay. So you want to check whether this is a max or a min, right?
Yeah.
Okay. So
Even then we're not going to know if it's an absolute because
Yeah.
we have to test the endpoints or the edges.
yeah, that's a good point. You guys see that? Even if I knew this thing was a max, it's only locally a max, right?
Yeah.
That's all that D is going to tell me, even. It's going to tell me is this locally a max or locally a min or a saddle. Knowing it was a saddle would stop me, right? I wouldn't worry about this point anymore. but knowing that it's a max or a min that wouldn't help me here. Good, see that? So what are you going to do with this thing?
Find the function value.
Find the function value and then set the whole thing aside. Okay? So over here, I'm going to set aside 0, 0. What's the function value? 4? Okay, so I set that aside for now. Now what do you need to do? So that was me checking for flat spots, right?
Yeah.
Sorry, where did we get 4 at?
I plugged 0 and 0 in here
Okay.
for x and y.
This is such a long process.
Yeah, these are long.
But, you know,
So here's the interior max, min, whatever, right? But on the outside, around the edges, what can happen? How do I check?
You can just use this one.
Yeah.
set y equal to 1, then solve for the
Yeah,
max
okay.
on that
So
line, and
let's see, there's
y
going to be
thing.
4 edges, right?
Yeah.
I'm not sure this is enough space. So they're going to be, okay, I'm going to start with y is 1, right? Then f of x and 1 is going to give you
X squared plus x squared minus 2x squared plus 8.
x squared minus 2x squared gives me minus x squared plus 8, you say?
Yeah.
Good. Cool. All right. Now this thing, what's that? And this is where your knowledge of, yeah, good. This is a downward facing parabola, right?
So the middle
guys see
point's
that?
going to be the highest.
So the middle point's the highest, right?
Yeah.
So where's the middle point?
0, 1.
Yeah, 0, 1. Okay, so I got to worry about this one. What are the other 2 interesting points? Where are the lowest this thing gets?
For this left and right.
For this left and right, which in this case are, so those are when x is positive and negative 1, right? And the y value for those points is going to be 1. So I'm looking at minus 1, 1, 1, 1. So far if I'm marking points I'm keeping track of the middle, and then it looks like edge, middle, edge, or edge, middle, corner. Corner, middle, corner.
What do those points stand for?
So these are the 3 points of interest. This one's the top of this function on the edge, so I'm going to have to check that one. This one's the bottom of that function on the edge, and this one's also the bottom of that function on the edge. You guys all see that? So I could even get the z values for these. You want to get them quick? So what's the z value for 0, 1? 0, 1, 8. How do you know it's 8? Yeah, I already plugged 1 in, right?
Yeah.
So I may as well just plug 0 in for that. Alright. How about negative 1, 1? So, yeah, if I plug that in, I get negative 1, 1, 7. Okay, and
1, 1, 7.
1, 1, 7. Okay, so far, right, comparing the 4 points I've accumulated so far, which one's top and which one's bottom? 0, 0, 4 looks like the bottom, and 0 and 8 looks like the top, right? You guys see that? Okay, what's the next edge you want to check?
Pick one.
Yeah.
Okay. So when x is 1, I'm looking at f of 1 and y. That's going to be,
So 2y squared plus
4
minus. Oh no, that's y squared.
4y squared
Yeah, never mind.
minus 2y plus Okay. That's a parabola again, right? Pointed upward. Minimum. Have to factor it.
Come on, Joe, you like factoring?
We can factor. We need two numbers that multiply to add to 2. Add to 2y, multiply to 20. You guys remember the AC factoring method? Cool. Let's learn it.
No, wait, no.
Never taught it.
No, I know.
Okay, so
I just
multiply these two numbers. 20. Okay, so I'm looking for two numbers that add to -2 and multiply to 20. Crap.
Let's see.
you have to go to fraction.
Yeah.
Drat.
It's not an easy one.
So we don't factor.
Okay,
Who has their
So-
inspire?
apparently we're not factoring.
Let's take the
How do I
derivative
find the
of
top and the bottom?
it. Take the derivative.
Yeah, okay. Take the derivatives another way, right? Okay, so
Way easier.
what's f prime of 1 and y? 8y minus 2. Looks like y should be
That should be
4 for a max, right? And then I should just check the corners because I'm not sure which one's higher.
Yeah.
Does it really matter?
That's our only flat spot.
Yeah, my only flat spots, right, on along this edge is when y is 4. There's two corners. I'm not sure which one's higher. I'm just going to check them both. So I'm looking at the point 1, 4 something, 1, 1 something, and 1, -1 something. What are your Z's?
Let's see, 1 and 4, so
Yeah, isn't that a 4?
oh,
Oh, fourth.
I know.
Cool. It's a quarter. My arithmetic's broken today too. All right. So what do you get when you plug a quarter in here?
it's a 16. 4 is 6. So 1.
So I get a quarter minus a half plus 5.
Quarter minus a half plus 5. Quarter minus a half
Is-
negative quarter.
1 1/4 or 5 1/4, right?
4
4
and 3/4.
Where'd you guys get the quarter at?
Oh, 4 3/4.
Quarter, a
It's
quarter
the 8y
minus a half.
minus 2, and you divide the 8 by the 2.
Okay. Either way,
Yeah.
it's 4 3/4, which is bigger than 4 and smaller than 8. So, what's the moral of the story about this point?
It's not in our bounds.
Or it's not an interesting point?
Yeah, it's not interesting in terms of being an absolute max or min, right?
On that plane.
You guys see that? In this square,
Yeah.
right? That one's not interesting to us. We're going to pitch that one. And really, we should pitch these others too.
Yeah.
Right, so far my reigning champs are 4 for the bottom and 8 for the top.
Yeah.
Okay, when I plug 1 and 1 in, what do I get out?
1 plus 4 minus 2 is 4. So 9, so 7.
7. Don't care. And
Same idea for our
Oh wait, it's the corners. They're gonna be the same. Or one corner's gonna be the same.
you guys see that? I'm doing this one, right?
Mhm.
One of the corners was the same. That was this one. Damn it.
You literally crossed it over too.
Okay, and then this one?
Okay.
It's the only 7.
So that
4
looks,
minus 2 is
But the 2 is tiny.
Negative 1. Yeah, it's a 11.
so that looks like I've got 4 plus 2 plus 5 is 11.
Yay, new reigning max.
Okay, so I can go back and drop that guy because this is my new reigning max.
Oh, I see why.
You're setting
see that?
it at 1.
Okay.
Let's go to the next
Yeah.
one.
Okay, x is -1.
Yeah.
sure.
And let's not get fooled, right? We should write down the ones we've already checked. We already checked over 1 and up a quarter, right? And this corner.
Yeah. Definitely.
Okay, and now I'm checking, now I'm doing this side, right?
Yeah.
So I already
Yes,
checked
yeah.
negative 1, 1, so don't let me check that one again.
Okay.
Isn't it going to be exactly the same as x equals 1? Because all the x's are
Negative
squared.
1y.
Ah, all the x's are squared. Good observation. Cool. You guys see that?
Yeah.
Yeah.
So f of x and negative 1 is going to be exactly the same thing.
Negative 1y.
You mean, yeah. Negative
Sorry.
x.
Negative 1 and y is going to be exactly the same thing.
So it's going to have all the same thing.
Yeah.
So it's going to
Including that corner, which is the highest.
going to have 4y squared minus 2y plus 5. And so I'm going to be, okay, I've got minus 1 a quarter and whatever. And then I should check the ends again. So I've got negative 1, 1 and something, and negative 1 and something.
Negative 1, 1 does not need to be checked again.
Yep, and I already checked the middle one. Okay.
So we should get still 1, negative 1, and 11. If they're the same function.
Because all the x's are squared.
All the x's were squared, but the y's are,
Well, we're plugging in the same y value into the same function.
thank you.
So we should get the same output.
Yep, good. You guys see that?
Well, then that means we could just skip that one.
Yeah, that's just gonna be boring. It'll be
Yeah.
for their x.
There's no way.
So across that.
Sweet.
Perfect. Cool.
I thought,
So it's in
I
there.
thought there's only supposed to be one option.
See whether, so there's two, it seems like I've got two spots where the max happens.
They can both
Yeah,
be
but we only
absolute
have one
max.
maximum value.
Yeah, there's one max value, right? The max value is 11. There's two places where it happens.
Okay.
Just like the absolute values in that.
But we're not done yet.
Yeah, and we're not done yet. So
Y equals negative 1,
I need to check y is negative 1 still.
which actually takes plugging in.
Yeah.
Okay. Crap. So I'm looking for f of x and negative 1. And I get x squared
3
Plus 2
plus 2x squared gives me 3x squared plus 8. Thankfully, that's another parabola, right?
No, wait, because when you
The-
put in
the
negative
y
1
turns it
for the
negative.
y, yeah, the 2
Wait,
becomes
never mind.
positive, so it's,
I have
Yeah.
my original
It's
function
six.
written on
3x.
okay, never mind, yeah. I don't know what's going on. Take a break.
Yeah.
It's been like
we're
over
done.
an hour.
Okay. We should only have one more point to check, right?
Okay.
Just finish it.
So let's finish it.
0, negative 1.
And the point is, yeah, the
root.
bottom of this, right? It's going to happen at 0. So I've got 0, negative 1, and
8.
8.
That doesn't have it.
What?
Oh, yeah, it doesn't have a y. But yeah, we have one.
Sorry, I'm just thinking weird things.
Okay.
I think everyone's hungry.
Yeah, it's just
Okay, so I got 0, negative 1, 8. What about this?
Doesn't matter.
Yeah, it doesn't matter. It's in the middle. What's up, Rick?
Fine.
Okay, so what I have here in the end is,
the maximum value.
yeah, so there's
And then a 4.
two absolute maxes, right? And one absolute min. The values, right, the absolute max value is 11, and it occurs at 1, negative 1, and negative 1, negative 1. And that absolute minimum value is 4, and it occurs at 0, 0.
Are we sure it's 0, 0, 4 though? Because I thought I got 5.
Well, if you plug in 0
No.
for x squared, you
Yes.
get rid of all that 4 is the only one that's outside.
Yeah, if I plug 0 in up here, I get 0, 0, 0.
Okay, excellent.
Cool? Check. Break time?